We're going to look at quadratic and linear systems. We had a big setup for this, but what we're going to do is kind of talk about the different ways to look at a quadratic and a linear equation. And then a system would be where, you know, if there's a quadratic where the linear line would intersect it, okay? So this is kind of a grade 11 university idea, but it makes you review quadratics and linears, which is, you know, grade 9 for linear, grade 10 for quadratic, grade 11 mixed for both of them. So kind of going over both of them. So, do you remember the equation for a linear system? That y equals something?
No.
No? Okay, so y equals mx plus b is the common way to write it. This is called like slope y-intercept form. So there's lots of different forms. This form is helpful because the m is your slope, right? And it's easy to graph a slope. And the b is the y-intercept, which is also easy to see. Okay, so we can just plug values in to this thing. What we'll do is we'll go to a graphic calculator here. We'll play with that. So let's say we had y equals mx plus b. So this asks us for sliders. So here's our line. And as we play with the slope, it obviously changes. Okay, and as we play with the y-intercept, it obviously changes up and down. So let's say we have a slope of 1. So I'm going to draw an equation on that. M is equal to 1. So we'll say y equals 1x. And the y-intercept is positive b. So we'll say plus, it's not positive b, plus 6, and there you go, it overlaps, okay? And you can kind of see as we change the b, it changes what it is. So let's say that's going to be our equation, 1x plus 6. So that'll be our equation for our linear system. Y is equal to, the slope is 1, x, and then the b is 6. So positive 6. And then a quadratic. There's tons of different ways to write quadratics. They can be written like in a factored form where we have 2 brackets. It's easy to find x-intercepts. You can write it in a vertex type form. It helps you find the vertex values. Or you can write it in standard form, which is like ax squared plus bx plus c. Okay. Any form is helpful. We're going to write it in the standard form. That way it's a little hard to tell if... actually, no. You know what? I'm going to make one up in vertex form. And I'll talk about y after. So let's say we have y equals, and vertex form is a x minus h, and then all of that is squared, plus k. Okay? And the reason I decided to put it in this form is because this one's going to be easy to graph also. Okay? And if it's easy to graph, we're going to be able to graph it by hand, and then we'll prove this linear system after using that. So let's make up some values for that also. So let's say we have, and I'll turn that guy off. Let's say we have y equals a x minus h power of 2 plus k. Okay, so we get some sliders for all of those, and we know the a value kind of changes it around. H value moves it left and right, and the k value moves it up and down. So if we zoom out a little, here's a question. As I move this up, do these intersect now, this linear system and this quadratic system? Are they cutting through each other?
No.
No. So if we were to do this, we'd find no solution. There's a possibility we could do... Oh, shoot. Let's see if I can get it right down there. Probably not. Oh well. Here we obviously have 2 solutions. Okay. I'll zoom in to see that a little better. And then you can kind of have an idea where it goes down to... I can't quite get it. But there's also a possibility where it only has 1 solution, and this isn't exactly it, but that would be where it only crosses once, okay? So we're going to make up some values here. Let's say we're going to make up our own equation here. We'll say that the a value, again, is, maybe we'll make it 1, okay? A will be 1, h will be negative 5. Work out good. And the k value is going to be 1. Yeah, let's do 1. Oh, that works out good. So that equation for that one would read, so we'll plug 1 in for a. We get y equals 1. X minus negative 5 is the same as writing positive 5. Okay, squared, and then plus 1. All right, so it overlapped the orange one, so we can kind of get rid of the orange one. We don't need it anymore. So we can see graphically that these intersect each other, okay? But we have to prove this algebraically. Okay, we know our purple line and our green line are going to cross. So let's write our equation again. We said it was y, whoops. What did we say? Y was equal to 1, x plus 5, I believe.
Yeah.
Plus 5, and then positive 1, I think, was our k value.
I think so.
Yeah. Okay. So we need to prove that these two things intersect algebraically. We can see it graphically. We just graph both of them. So what we're going to do is think of substitution with linear equations, right? Both of these are set equal to a variable. They're both set equal to y, which means that if y is equal here and y is equal here, we can substitute, all of this in for this value of y in this equation. Okay, so we're going to do that. We're going to put this in for the y value. So I'll write it in red. We get 1x plus 6 is equal to, so we use that to replace the y, 1x plus 5 squared plus 1. Okay, so we've set them equal to each other. And this could be written in any form of quadratic. But the whole thing now is to get everything onto one side. We want one side to be equal to 0. And then we're going to expand and collect like terms. Okay, so if I move positive 1x to the other side, what will it become? This positive, when we move it to the other side of the equation.
Oh, it'll become negative.
Yeah, it's going to become a negative 1x. And when we move this positive 6 to the other side, what will that become?
Negative 6.
Negative 6, good. So we get, now this 1 multiplied in front, do I need to include it 1 times this? Is that going to be important? No, because 1 times anything is just whatever that is, right? So we'll write x plus 5 squared plus 1 minus, again, we don't have to write that 1 in. We'll just say minus x minus 6, okay? And on this side, we are now 0. So that's really important. Once we set stuff equal to 0, we can start to use different formulas to solve things. So now I have to expand, okay? So because we're expanding on the right side here, this is the bracket, and when it's squared, it's just that bracket times itself again. Okay? We still have everything else on the outside. Nothing else changed there. And we're going to use FOIL. Do you remember FOIL? Where we do the first term by each other, last terms, then inside, outside terms, okay? You could also call it the rainbow method, whatever it is. And we're going to end up with x times x is x squared. Okay? X times 5 is 5x. 5 times x is 5x. 5 times 5 is 25. Okay, so that's everything from within the brackets. And then we still have everything from outside the brackets, which is plus 1, minus x, minus 6. So we have a whole bunch of like terms. So we're going to try to figure out what they are. We have x squared. Does it have any other like terms in here? Is there any other x squareds?
No.
No. That's the only one of its kind. Okay. What about values of just x? Like 5x. Is there another like term?
Yeah, another 5x.
Another 5x. Anything else?
Negative x.
And the negative x. Those are all like terms. And what about 25?
The 1 and the negative 6.
Perfect. So those are the only ones we're going to put all together here. So we have 0 is equal to x squared. 5x and 5x is 10x. Minus 1 is going to be 9. So we're left with 9x. And then 25 plus 1 is 26. Minus 6 is 20. Okay. So now we're left at 20. So we have, this is what normally a quadratic looks like. And this looks like it's actually in the standard form of a quadratic. And within standard form of a quadratic, if you want to solve for the x values, you can factor, right? So we can go through our factoring. We're not 100% sure this will factor. I'm going to tell you it does. Or what we commonly use is the quadratic formula to solve this, okay? Luckily, this one factors. So I'm going to use some factoring. And because this a value is only 1, we can use a really, really basic style of factoring. We can look for just 2 terms that are factors of 20, so 2 terms that multiply to equal 20. And those same 2 terms need to add up to our b value, which is our 9. Okay. So 2 terms that multiply to positive 20 and add to 9, I know them already. They're going to be 4 and 5. Okay. So because this is such a basic form of factoring, this works out really nicely. We'll have x plus 4 and x plus 5. Okay. So that's done there. Now these 2 values, or these brackets, multiply to get 0. Well, in order to multiply to get 0, something has to be 0. So we're going to split these brackets and set both of them equal to 0. So we get 0 is equal to x plus 4. And we also get 0 is equal to x plus 5. Okay. And then we solve for our x values. When I move 4 to the other side, what will it become?
Negative 4.
Yeah, and when we move 5 to the other side, what will it become?
Negative 5.
Okay. So we have our 2 x values. We know that the linear and the quadratic function both intersect. So I'm going to do a rough sketch with the information we have here. We know that the linear and the quadratic, so let's say here's our quadratic and here's our linear. I don't exactly know. But we know they intersect at negative 5 and negative 4. Okay? And was this a positive one? Here, I need to look. Yeah, it was. Okay. Now, if we go to our graph on the other page, We already know that. -4 and -5, those are the x values. But what about finding the y values? How do we do that? Well, when we go back to the top, we have a choice. Since the linear function and the quadratic functions all go through those same points, we can plug in those x values in the quadratic or the linear. Which do you think is going to be easier to solve for? Plugging things into this quadratic or plugging things into this linear function?
The quadratic.
Yeah, this will be much harder to solve for into this quadratic function here. Because when you plug it in, you're going to have to add, square it, multiply by 1, add 1. If we plug it into the linear, we multiply and add. Far less steps, okay? So let's use the linear function. 1x plus 6. Did you say that or did you say the opposite? I didn't hear it. You don't know? Okay, whatever. Y equals 1x plus 6. Okay. So we're going to replace, or we're going to write the equation twice. Y equals 1x plus 6. And we're going to use different values. In this one, we'll replace x with -5. And in this one, we'll replace x with -4. And it'll tell us the two coordinates, the actual y values of them. So y is equal to 1 times -4 plus 6. Okay. And y equals 1 times -5 plus 6. Okay. So we're getting our two y values. Y is equal to -4 plus 6, which is y equals 2. And in this one, y equals -5 plus 6, which is y equals 1. So the coordinates are, since we plug -4 in, we have x value -4, y value +2. So that's one of the points of intersection. And the other point of intersection, the x value was -5, and the y value was 1. Okay, so we have -5, 1 as one of the coordinates, and we have -4, 2. And that makes sense because it's sloping upward. So that's the points of intersection between these values here. Okay, so there's a ton of steps, and we can tell that's exactly what we got. These are the coordinates we got when they intersected each other. Okay.